All right, here we go. Everybody ready? Yesterday we talked about line segments and we talked about the segment addition postulate where we were able to add two segments together to get a bigger one, or we were given the big one and we would subtract to get one of the smaller ones. So today we're still talking about line segments, but we're going to talk about something just a little bit different with those line segments. So in that first sentence there, it says, if two geometric figures have exactly the same size and shape, okay? The same size and the same shape. Then they are what we call congruent. Stop. Sorry. Okay, congruent. Now, we have a symbol for congruent. I'll show you that in just a minute. A lot of times, instead of writing the word congruent, I just use the symbol because it's quicker. Not to mention, we don't have to worry about how to spell it, okay? If two segments that, I'm sorry, not if, but when two segments that have the same measure is the next one. When I'm talking about the measure of a segment, I'm talking about how long it is. So if we have two segments that have the same length, the same measure, they are what we call congruent segments. Okay, exactly the same size, exactly the same shape. So for example, if I'm talking about these two markers here, would we be able to say that they are congruent? Are they exactly the same size and the same shape? Mm-hmm. They are. And these two are congruent. Would these two be congruent? Mm-hmm. No, not the same shape, almost the same size, but not the same shape, so therefore they can't be congruent. Congruent has to be exactly the same shape, same size. Does that make sense? Now, the symbol for congruent looks like this. It is an equal sign. If I can get my tablet to work. It is an equal sign with a little squiggly on top of it. That's what the word congruent means, and that is read as congruent to. So anytime you see this symbol here, I'm going to highlight it, maybe. Anytime you see that symbol, that means congruent. And again, I use that symbol a lot rather than writing the words just because I get lazy sometimes in geometry, especially writing about a bunch of stuff when we get to proofs later, that you're going to want to use the symbol. I can't even talk. Symbol. And then the rest of the sentence, it says tick marks on the figure also indicate congruence. So if you take a look at your picture, do you guys notice that you have these little, they're black and white on your paper, but that you have these little tick marks on your segments? Do you see those on your paper? Those tick marks tell me that those are congruent. So if I didn't even have a length given, if I had those two little tick marks, then I could say, okay, well, those segments have the same length and they're same size, same shape, they're congruent. If we have multiple pairs of congruent segments, for example, if I were to draw another pair of segments and call this one EF and GI, okay, what I would do is I would do two tick marks on each of those to say that those two are congruent, but they're not congruent to the first two. Does that make sense? Do you see how I added another tick mark? That differentiates between which pairs of segments are congruent. Anybody have any questions so far? All right, let's take a look at your first example. It says we've got a segment P, R, and then Q, it looks to be there somewhere in the middle. And then what do you notice on your picture? There are little tick marks here, which means that PQ and QR are congruent, which means they have exactly the same length. So what I need to do then is I need to solve this for X. So look at your picture. What is the length of PQ? What does it have it labeled?
6x plus 1.
Okay. And if they're congruent, that means their lengths are what? Exactly the same, which means what in math? What symbol uses exactly the same? Equals, yeah. Mm-hmm. And it is equal to the length of QR. What is the length of QR in our picture? 2 parentheses x plus 6, yep. Distribute it, yeah. Mm-hmm. Ready? We need to solve this equation. What's the first thing we need to do to solve this equation? distribute, we need to get rid of those parentheses, right? So that 2 that is on the outside of the parentheses, excuse me, needs to get multiplied by both the x and the 6 inside the parenthesis. That is what we call distribute. I'm going to leave the other part alone. I'm going to come over here to the side so I have some more room. I'm going to leave 6x plus 20 alone because I don't have any parentheses there. And I'm going to multiply 2 times x, which gives me 2x. And then I'm also going to multiply 2 times that 6, which gives me 12. And now I just need to get all my x's on one side of my equal sign and all of my numbers without an x on the other side. Keep in mind that your equal sign is like a fence. You want the variables on one side of the fence. You want the numbers without variables on the opposite side of the fence. What would you recommend I move next to solve this for x? You want me to move the 12 over to the 20? Okay. So I'm going to subtract the 12 over to the 20. Remember, with equations, there are multiple ways that you can solve them. What is positive 20 and negative 12? Going to give me what? Positive 8? All right. What next?
Divide 2.
Okay. Now, if, yeah, we do want x by itself, right? So if that 6x weren't there, if it were just 8 equals 2x, then yes, we would just divide by 2, okay? However, do you notice we have an x on the left side of our equal sign and an x on the right side?
You want to divide the x's, right?
Yeah, I don't want to divide yet, though. I'm not quite to the dividing part. I want to move this 6x over here to that 2x, right? Because I want to get it on the opposite side of the 8. Is that 6x positive or negative? It's positive. So to move it, we're going to have to subtract it, yeah. So what I'm going to do is I'm going to take and I'm going to subtract my 6x over to the 2x, get it to the other side so I can get my x's together, so then I can work on my dividing. And then if I have a 2 and a negative 6, negative 4x. Now what would we do? Divide. And we want to get that x by itself, so we're going to divide by negative 4. Because I need all of my x's on one side of the equal sign. And with the 6, I had a 6 on the left side and I had the 2 on the right side. So I needed to move that 6 away from the 8 and get it with the other x's. And then what is 8 divided by negative 4? Negative 2. Now here's where we have to be careful, and I don't really like this example so much as with the negatives. We are talking about the length of a segment, correct? How long something is? Can you ever have a negative length? No, when you measure something, it's always got to be positive. But what I need to do is just look back at my stuff. If I plug a negative 2 in there, 6 times negative 2 is what, negative 12? Negative 12 plus 20, that would give me 8. So that still gives me a positive length, even though I got a negative number, right? The reason I'm mentioning this is just be careful if you get a negative answer, because if it had just been x, we couldn't have a negative answer. You can't have a negative length. But in this case, it's okay. So we get x equals negative 2. Excuse me. All right, let's take a look at that next example. Do you see where it tells you that segment CK is 174 centimeters long? Okay. And then the 2 questions it's asking you to find CG, and it's also asking you to find GK. However, what variable is in my picture? W. So I probably need to find W first, right? So let's take a look. Sorry, things might work. CK, so the length between C and K is 174 centimeters. From C to G is 8W plus 5. From G to K is 5W. What do you think I need to do with CG and GK to be able to have it equal the whole thing? Add them. So let's start out. Do your CG, your 8W plus 5, plus your other small segment, GK, the 5W, and that would equal the whole segment, which is how much? 174. Some people have a little bit of difficulties with the equations.
It's 5W.
Thank you. I just noticed that as I was stepping away. Some algebra issues that we have with questions like this is people see the 8W and the 5W and they think that they need to subtract the 5W to the 8W. Okay? Do you notice how they're both on the same side of my equal sign though?
Yeah.
When that happens, you don't do the opposite. You just combine them. They're on the same side of the fence. They both have a W. So what I'm going to do is I'm going to combine them first. What is 8 plus 5?
13.
13. So that's going to give me 13W. Then I just bring down that plus 5. And that is equal to 174. We want to get W by itself. So I need to get rid of my 5. How would I move my 5 to the other side? Subtract it, yep. Bring down that 13W. 174 minus 5 is what, 169?
Yeah.
Okay. And then to get W completely by itself, we're now going to divide by 13. And what is 169 divided by 13? 13. So W in this case, excuse me, is equal to 13 after we solve our equations. Is that what we're asked for though?
No.
No, we're asked for CG first. How did we represent CG? What's it represented as in your picture? 8W plus 5. But what do we know W is? 13. So we're going to plug that in so that we can find the length of it. Stop. Let's see, 4. Come on. 2. This would be 104 plus 5, which is 109. Okay. And then for GK, we do exactly the same thing, except for we plug it into what GK is. GK is 5 times W. So we do 5 times 13, which gives me 65. So there's one answer. There's the other. We had to find W first before we could plug it in and find the other one. Everybody okay with that? Anybody have any questions? All right. On a number line, do you see that number line there where you go from -8 to +4? We want to decide if each statement is true or false. So what I want you to do is look at that first statement. It says CE. Look at your number line. Tell me how long CE is. How many units are between C and E? 2, right? If we start at C and we count over to E. So here's C. We count over 1, 2 to E. So that tells me 2, right? So CE has a length of 2. Excuse me. What about EH? Count that for me. Start at E, end at H. 1, 2, yep. Wait, 1, 2, 3, yeah. And then we want to count CH. Start at C and count to H. 1, 2, 3, 4, 5. Does that make a true statement or a false statement? It makes it true. 2 plus 3 is 5, so we're just going to write true.
That's what we want to touch.
Something similar, but not quite. We are going to do number lines, but we're going to do a little bit something different with them. Go ahead and try D. That's the last one, isn't it? Yeah, count DJ, count JG, and then count DG. And decide if that makes a true or false statement.
We got homework?
Always. How long is DJ? Hold on, I can't. Let's see, from D to J. 1, 2, 3, 4, 5, 6. Okay. What about J to G? Okay. Question though, can you have a negative length of a segment? No, even though you went backwards, you still have to have a positive length. So what would that be? positive 3. And then from D to G is 3. So is that a true statement or a false statement? False. Okay, so be careful with that. If you had put negative 3, it would make it look like it's true. We cannot have a negative length of a segment. Okay, so when you're counting the length of a segment of a number line like that, you have to always have a positive number. Does anybody have any questions about any of that? All right, so today we're done with our notes super early. You got the next, what, 21 minutes to work